Greetings, pre-calc students, and welcome to our next video on properties of logarithms. So we're going to learn about some properties. We're going to expand logarithmic expressions and condense them. We're also going to use the change of base formula. All right, so here are 5 important properties of logarithms that we're going to go through. I'm going to just list them here now. This is a reference for you, and then we're going to go through each one individually in this video and learn how to use it. So this is a good reference sheet for you. Again, this might be something you want to put on your note card. The first one we're going to go into is using the definition properties of logarithms. So there's 3 definition-based properties, and they're called this just because using exponential form sort of explains why these properties all work. The first one says that log base b of 1 is 0, and this is always because any number to the 0 power is equal to 1. So that's why that property always works. It doesn't matter what the base is. The second property says log base b of b is 1. That means that if you take b to the 1, you get b, no matter what your base b is. And finally, if you rewrite the last one in exponential form, it tells you that b to the nth power is equal to b to the nth power. That's what that says. So these are little shortcuts and things you should understand based on the exponential form of logarithms. So let's practice with them. So the first one says log 10, no base written, so that means base 10. Log base 10 of 10, that's going to be this property right here, and that's going to be 1 because 10 to the 1 equals 10 to the 1. Log of 1, always 0, because 10 to the 0 is 1. Why don't you guys pause the video and try the next few on your own? Oops, I don't know what I'm doing when I do that. Why don't you guys pause the video and try the next 3 on your own, and then I'll go over them with you. All right, how did it go? Well, let's go ahead and go over your answers. Remember, ln is natural log, so that's base e. So this is going to be equal to 1 because e to the 1 equals e. And this one is going to be the last property, because we can write this as log base 3 of 3 cubed. Now, if you don't want to do it this way, if you just want to remember that 3 cubed is 27, totally fine. But this is just practicing using that property. And similarly, we can write this as log base 2 of 2 to the, 2, 4, 8, 16, 32, 64, 6. So that tells me it must be 6. And again, on these, if you would like to rewrite them in exponential form so you don't have to memorize these formulas, totally fine. They're just properties that we're exploring. All right, the next property we're going to talk about is the change of base property. We use a change of base property if you don't have a calculator. So if you're using Desmos scientific calculator on your computer, it can do any base, and it can use a calculator approximation for any base. But a lot of calculators don't do that. So we use the change of base formula if we want to get a decimal approximation for a logarithm that isn't base 7 or base 5. So what the change of base formula says is if you have log base b of some value m, you can change it to any base you want. So our new base is base c, and it's log base c of m over log base c of b, b being the original base. So let's practice using this. I'm going to go ahead and plug in the formula, and then I'll draw my calculator up, and we'll give it a try. So my base is 7. So if I'm applying the formula, b is 7 and m is 21. So I'm going to switch to log base 10. So this would be log of 21 over log of 7. And so if I pull my calculator up here, which I don't have handy, but I can open real quick, and I want to know what log of 21 over log of 7 is, I can do 21 log, and I get 1.32 approximately. And I can do log 7, and I get 0.85. And then I can divide those two numbers. So let's clear this out. 1.32 divided by 0.85. And I get it's 1.55 approximately. And I guess I should use my approximately symbol here. So why don't you try the second one, log base 5 of 37. Use a change of base formula and a calculator to get an approximation for that value. All right, are you back? Okay, so this would be log 37 over log 5. And you could use natural log if you wanted to. I just didn't want to. So let's first find log 37. And it's 1.57. And let's find log 5. And it's 0.70. Rounded to 2 decimal places. So let's divide those two numbers. Oops, I hit the wrong button. 1.57 divided by 0.7, which is 2.24. So you can use a change of base formula to find decimal approximations for logs other than base 10 or base E. All right, now we're going to talk about the product property of logarithms. Remember, logarithms are just exponents. So we have this from exponents. Remember this rule of exponents that we used, that you went over whenever you took some other algebra classes, hopefully? There's this rule of exponents. And it says that any base to a power of m times base to the power of n is equal to base to the power of m plus n. Because you have m copies of the base here and n here, so that gives you a total of m plus n copies. So if we want to write this in like number form, it's sort of like saying that 2 to the 5th times 2 squared would be equal to 2 to the 7th. And that makes sense because if you write this out, you really have 5 2's and then 2 more 2's, and that gives you a total of 7 2's. So that's how that exponent property works. And hopefully that kind of, if you've forgotten that now, you're kind of remembering that. Since logs are exponents, this property carries over to logs, and it looks like log base b of a product, m times n, equals log base b of m plus log base b of n. So we use this to simplify expressions. So let's go down and give it a try with this first one here. I have no idea what I'm doing that makes it do that. So we use this to simplify expressions, and let's give it a try with example 3a here. So we have log base 3 of 9 times t, so our product is 9 times t. So we're going to apply the product property and get log base 3 of 9 plus log base 3 of t. Now, we can't do anything to simplify log base 3 of t at this time because we don't know what t is, but we do know that log base 3 of 9 is 2 because 3 squared is 9. So this becomes 2 plus log 3 of t. Now, whether or not this is more simple, I'm not sure, but it is called expanding. So if we want to expand a logarithm, this is the property that we're going to use. Why don't you guys try example B? Pause the video and try example B. Okay, so when I touch it, I must be holding down. All right, did you give it a try? So this is log of 10,000 plus log of W. 10,000 is 10 to the 4th, so that's 4 plus log W. All right, let's look at C together. We have the natural log of this quadratic expression, and that's not a product. So what do I need to do here? Well, it doesn't say to do it, but when you see something like this and you're supposed to be using the product property, it means I need to write this as a product, which tells me I need to factor this. So let's go ahead and factor this expression. I'm going to use a big bracket and factor v squared minus 4v minus 12. So it's going to be v and v. What multiplies to negative 12 and adds to negative 4? I guess it would be v minus 6, v plus 2. So that's v squared plus 2v minus 6v gives us minus 4v minus 12. So now I do have a product, and I can use the product property. So that's the natural log of v minus 6 plus the natural log of v plus 2. And we don't have to always use the property from left to right. So let me just zoom out a teeny bit here. Oops, I didn't hit the right button first. If we look at the product property, sometimes it might be used. We've been starting with the product and writing out it as a sum. Maybe we start with the sum and go back and write the product to help us condense. So let's look at the example D. We have log base 4 of 2, which isn't going to be a very nice number, and log base 4 of 8, also not going to be a nice whole number because there's nothing to raise 4 to get to 8. So we're going to use the product property, but starting on the right and working to the left would be log base 4 of 2 times 8, which would be log base 4 of 16, which is, in fact, 2, because 4 squared is 16. So you can use the property both ways in different situations. Right, well, we have a product property, so now we're going to talk about the quotient property. This comes from exactly the same idea as the product property because logs are just exponents. So if we have b to the m over b to the n, that is b to the m minus n. An example really quick would be like if you had like 2 to the 5th over like 2 cubed, well, that would be like having 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. And of course, 3 of these would cancel out at the top, and you would just be left with 2 squared, which is exactly 2 to the 5 minus 3. So that's why that property works for exponents. The same property is going to work for logs. If you have the log of a quotient, it's equal to the log of the numerator minus the log of the denominator. So let's practice using this quotient rule for logarithms. All right, so this is going to be log of x minus log of 1,000. Log x we can't really do much with, but log of 1,000 is 3 because 10 cubed is 1,000. All right, why don't you guys try the next 2 problems? All right, how did it go? Hopefully it went well. Let's go through it. So this would be log base 5 of 125 minus log base 5 of y. 5 cubed is 125. So we can simplify this to 3 minus log base 5 of y. All right, let's keep going. Natural log of e to the 4th minus the natural log of 8. Well, the natural log of e to the 4th, remember that's base e, so e to the 4 would be e to the 4th, so that makes that 4 using our definition-based property. 4 minus natural log of 8. This one's all set up for us. Log of w minus 3 minus log of w plus 2. And now going back the other direction. So let me just zoom out a little bit so we can see the property. Again, we're going to start on the right, and we're going to condense to form a single logarithm. We have the natural log of a plus f minus the natural log of a minus f. So this condenses to a single natural log of a plus f over a minus f. And sometimes when you're simplifying, that's going to be useful as well. All right, a couple more properties here. Let's talk about the power property of logarithms. So for exponents, we had the property that if you have a base to an exponent to another exponent, you multiply the exponents. And again, that would be like if you had 2 cubed and you squared it, it would be the same as having 2 cubed times 2 cubed, which would be 2 to the 6th. And sure enough, that's 3 times 2. So you have 2 copies of each of those based on the addition property of exponents. That's how that would work. The same thing works for logs. If you have log base b of m to the pth power, that would be p log base b of m. So I like to just think about the p coming down out in front. And this can also help us simplify logarithms. Let's go ahead and practice using this property. Log of x to the 7th becomes 7 log x. Log of m to the negative 8th becomes negative 8 log m. Why don't you guys try the next 2? They're a little bit trickier. Give them a try. All right, are you back? Did you remember that the square root is t to the 1/2? That's the same as natural log of t to the 1/2. So that will be 1/2 natural log t. And finally, this would be w plus 1 log base b of v. So that one's a little bit tricky. You got to make sure you get that w plus 1. And then if you wanted to distribute, you certainly could. All right, so we're going to use these properties to expand and contract logarithm expressions. So the first set of directions says to fully expand log x times y cubed. So the first property we're going to use is our product property. All right, so we're going to use our product property, which says log base b of m times n equals log base b of m plus log base b of n. That's the first property we're going to use, and that's going to tell us that we have log of x plus log of y cubed. All right, so we're not totally done because we have this y cubed. Now, if we remember back to our power property, which we just did, it said that log base b of m to the p is p log base b of m. So let's write that one down. Log base b of m to the p equals p log base b of m. So we're going to use that property now, not on the log of x. That one's done. But on this one, we have this y cubed. We want to get that out of there, so that becomes plus 3 log y. All right, let's try another one of these guys, and then I'll give you a couple to practice with. So this one is a division problem. Actually, why don't you pause the video and give this one a try? I think you guys can do this one. Give this one a try. All right, so we're going to use the quotient property. First. So that is log of root t minus log 25. Now there's nothing we can do with log 25, but root t has a power on it. So we can remember that t, the square root of t is t to the 1/2. Just going to cross that out and write that as t to the 1/2. That comes down in front. So this becomes 1/2 log t minus log 25. All right, let's try this next one. We'll do this one together. So we have a quotient, and inside the quotient we have products, and inside the products we have exponents. So the first thing we have is a quotient, so let's use the quotient rule first. So this is the natural log of x cubed y minus the natural log of z squared w. All right, now we use the product rule because this isn't all cubed, it's just x cubed, so we got to get down to that part by itself. The natural log of x cubed plus the natural log of y minus the natural log of z squared. And be careful here. You can put a bracket around this, plus the natural log of w. You need to be careful there with your sign because the whole natural log product is being subtracted. So we need to subtract the natural log of z squared, but also once we distribute this, we'll be subtracting the natural log of w. It was in the denominator originally, so we know it should have a negative coefficient. All right, and now let's go ahead and distribute that. So natural log of x cubed plus natural log of y minus natural log of z squared minus natural log of w. And finally, we use our power property. So the 3 comes down in front here, and the 2 comes down in front here. So 3 natural log of x plus natural log of y minus 2 natural log of z minus natural log of w, and that's a minus. Excuse me. All right, fully expanded. And now that we can fully expand things, let's learn how to fully contract them. So it's kind of just going back the other way. So in this example, we have a sum. Nothing crazy is going on here. In fact, we could simplify this ahead of time, but we won't. Let's use let me just take this moment to say there's a lot of different ways sometimes to find the value of logarithms. We know that log base 2 of 2 is 1 and log base 2 of 32 is 5, but let's use the formula and then simplify. So this would be log base 2 of 2 times 32, which would be log base 2 of 64, which we all know should be, I think, 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Oh, it's 6. Because 2 to the 6 equals 64. Could we have done that right at the beginning? Yeah, we could have gone 1 plus 5, sure. But we wanted to use the formula. All right, let's try this one. we're going to simplify this one. We have log of 3s plus 7 minus log of s. We're going to use the quotient formula. So it's log 3s plus 7 over all over s. And there's nothing else you can do there. Those s's don't cancel because remember the numerator is a grouping symbol. Let's keep going. This looks like a good one. Let's fully contract this one as well. All right, so we see we have natural log of 2x to the 4th plus 2 natural log of x to the 5th minus log of y cubed minus 1/2 log z. So the first thing I'm going to do is I'm going to get rid of these coefficients. So it's going to be natural log of 2x to the 4th plus natural log of x to the 5th squared minus log y cubed minus log z to the 1/2. All right, now when I'm looking at these, I'm noticing these first two, let's just take them as they come, are both natural logs and they're added so we can use the product property. So this is natural log 2x to the 4th times x to the 5th to the squared is x to the 10th minus log base 10 of y cubed minus log base 10 of z to the 1/2. So this becomes natural log of these, we add those exponents of 2x to the 14th minus, and I'm going to factor out that minus sign, log of y cubed plus log of z to the 1/2. And I factored that out because they're both being subtracted. So I wanted to be able to add those logs using my product property. And with that minus sign there, it made it difficult to use that property. So if I factor the minus sign out, they're both still being subtracted, but it's just written a little bit more easily, more nicely. So this becomes minus log base 10 of y cubed z to the 1/2. And that's basically all we can do there. We can't combine these two logarithms because one is base e and one is base 10. So there's nothing else you could do. You probably don't need that last set of parentheses, but it's not hurting anything. All right, why don't you guys try number 12? Give it a try. Use all your properties of logs and try and figure out what this equals. Don't use a calculator. All right, did you get a value? Well, let's give this a try. The first thing I'm going to do is I'm going to get rid of my exponents here. That goes up here. And I'm going to put the 4 up here. And this one doesn't have a coefficient, so I'll leave it. So this is log base 9 of 3 squared minus log base 9 of 3 to the 4th plus log base 9 of 1 over 81. All right, let's figure out what those are. So that's log base 9 of 9 minus log base 9 of, well, that would be 81 plus log base 9 of 1 over 81. Now, at this point, I think we can figure out what all those logs are equal to, but let's just keep using the properties for fun. All right, so this is going to be log base 9 of, so this is a subtract, so it's 9 over 81 plus log base 9 of 1 over 81. This is a product property, so this is log base 9 of 9 times 1 over 81 times 81, which is 81 squared, which that I don't know off the top of my, oh, good, I have a calculator right here. What's 81 squared? 6561. All right, well, what is this equal to? Well, let's see. What, oops, 9 divided by, let's see what that, if we divide that by 9, we get 729. So this is log base 9, reducing the fraction to 1 over 729, which I happen to know is a power of 9 because we just calculated a bunch of that. So let's figure it. I think it's going to be 9 to the 4th or something. So let's do 9 times 9. oops, what am I doing here? 9 times 9, 81 times 9 equals 729. So that is 9 cubed. So this is log base 9 of 9 to the negative 3, which equals negative 3. Now, arguments could be made that it would have been easier to stop at this point where we said if we stopped here, we know log base 9 of 9 is 1. Log base 9 of 81 is 2. And log base 9 of 1 over 81 is negative 2. So that would have been 1 minus 2 minus 2, which would be negative 3. It might have been easier to stop there, but we did it both ways. All right, well, that's our video on properties of logs.